Okay, we need to practice a little bit on identifying strong and weak electrolytes. Let's come up with some general categories. Most salts are strong electrolytes. So for salts, what I want you to think about here are simply ionic compounds. Now technically a salt is a cation and an anion from an acid-base neutralization reaction, but most salts are strong electrolytes. Not all, but most. So if it's an ionic compound, you're probably thinking strong electrolyte. Most acids are weak electrolytes. However, you've got the big seven, which you need to memorize. Those are your seven strong electrolytes: hydrochloric, hydrobromic, HI, HNO3, H2SO4, chloric acid, and perchloric acid. Those are all strong acids, therefore strong electrolytes. The common strong bases are the hydroxides of the alkali metals and the heavy alkaline earths. Ammonia is a weak base and a weak electrolyte. Most other substances are non-electrolytes. So let's take a look at the alkali metal hydroxides. Here's group 1. These are the alkali metals, excluding hydrogen. It's not a metal, it's a non-metal. So we're talking about lithium, sodium, potassium, rubidium, and cesium hydroxide, and the heavy alkaline earth hydroxides. So these will be the strong bases that you need to be familiar with. And let me show you what those look like. So that's going to be lithium hydroxide, sodium hydroxide, and we're just going right down the list: potassium hydroxide, rubidium hydroxide, and cesium hydroxide. Now notice that hydroxide has a -1 charge. All of the alkali metals have a +1 charge in ionic compounds, so it's a 1 for 1, but these are the group 2 metals. They have a +2 charge in ionic compounds, and so calcium hydroxide will have 2 hydroxides per calcium ion. And then strontium hydroxide, same thing. Got 2 hydroxides. And then you have barium hydroxide. And so there you go. You got 1, 2, 3, 4, 5, 6, 7, 8. 8 strong bases, guys. And I need to make sure you understand that when calcium hydroxide and strontium hydroxide and barium hydroxide dissociate, they dissociate to calcium 2+, and we're putting them in water, and 2 discrete hydroxide ions in aqueous solution. And that'll be true for strontium and barium hydroxide as well. Just dissociate them in the same way. So this is a twofer for the strong bases. Okay. Let's talk about your one weak base that I've given you, and this is an amine base, and this is going to actually be true of all the amine bases. Ammonia is the simplest amine base. It's NH3, and when I put it in water, good old H2O, get some acceptance of a hydrogen off here. This gives me the ammonium cation, NH4+, and every time one of these hydrogens comes off of water, it leaves an OH- in aqueous solution. So this is a weak base and a weak electrolyte, and it produces ammonium ion and a little bit of hydroxide ion. That's why it's a weak base and not a strong base. This is ammonia, and you should remember that. All right, let's ask this question. Classify each of the following compounds as an acid, a base, or a salt. And so we have potassium nitrate. You remember acids, they have hydrogen in them, so it's not an acid. The bases that I've given you, other than ammonia, have OH minus in them, and so it's not one of those. So this must be a salt. So piece of cake. This we've got some familiarity with. It starts with H, so good chance it's an acid. It's hydrofluoric acid. It's actually a weak acid, but it's an acid. All right, so we'll go down here, and we see that B is our answer. Potassium nitrate is a salt, and HF is an acid. Let's do a little electrolyte practice and put these compounds in categories as acid, base, salt, or molecular. And depending on whether it's an acid, base, a salt, or molecular, strong, weak, or non-electrolyte. A couple of things to remember. Strong bases are strong electrolytes. Strong acids are strong electrolytes. Most salts are strong electrolytes, and most molecular compounds, other than your acids, are non-electrolytes. So here we go. So this is NaOH. It's an alkali metal. That's a group 1 plus 1 alkali metal hydroxide. That's definitely a base. And it's not just a base, it's a strong base. And if it's a strong base, it dissociates completely, which means that it's a strong electrolyte. All right, let's take a look at this guy. There's no hydroxide, no hydrogen ion. That is a metal, that's a nonmetal, so this is going to be a salt, and most salts that you will encounter are strong electrolytes. Okay. This is nitric acid. It starts with H. That's what your tip-off is, that this is an acid. And it's actually one of your strong acids. So it's definitely an acid. All you got to do is see that H that it starts with, and it's a strong acid. It's one of the 7, so it's a strong electrolyte. What does that mean? That means that HNO3, when it ionizes completely. And when it ionizes completely, it conducts an electric current to a strong degree. And so we call it a strong electrolyte. Now, most people are going to look at this, they're going to see that OH, and you're going to say, oh, that's a base. Except that this is carbon and hydrogen. So this is not an alkali metal hydroxide. This is not a heavy alkaline earth hydroxide. As a matter of fact, this is not a hydroxide at all. This is an alcohol. This is a molecular compound. And what do you know about most molecular compounds? They're mostly non-electrolytes. This is HF. You see the hydrogen out there. That tells you that it's an acid, pretty reliable, but it's not one of your 7 strong acids, so that means it only partially ionizes in solution, which means that it's a weak electrolyte. Okay? So I've got the answers in there for you. And so there you go. All right, let's keep going. Types of reactions. We have 2 general types of reactions we're going to talk about. We're going to talk about metathesis reactions. Metathesis reactions are what we call double replacement reactions. They swap partners. So you'll have essentially 2 compounds, and the cations and the anions will swap places with each other. Two forms of those are precipitation reactions and neutralization reactions. These are the acid-base reactions that we've been talking about. Then we have a very powerful category of reactions called reduction-oxidation reactions, and we'll talk about those. So let's deal with metathesis reactions first. So these are sometimes called double replacement reactions. I sometimes call them swingers reactions because here are two compounds, and what they do is they swap partners. So there's this exchange of the AX comes to the party as AX and leaves the party as AY. BY comes to the party as BY and leaves the party as BX. So there you go. So they do replacement. Here's a real metathesis reaction. This is silver nitrate. It's a soluble ionic compound. Potassium iodide, also a soluble ionic compound. And they form an insoluble salt, which we call a precipitate, known as silver iodide, and then we have potassium nitrate, which is a soluble ionic compound. All right, so that's what these guys stand for. A stands for silver cation. X, in this case, stands for the nitrate anion. B stands for potassium ion. And Y stands for the iodide ion. And they're just going to swap partners. That's what they do.